Okay, so what's the agenda for today? Let me just tell you the agenda. Okay, so today I want to go back to the discussion of light. So I started mentioning that there were some problems with electricity and magnetism and light, is that Maxwell's equations, which describe electricity and magnetism, are not Galilean invariant. So this was a big problem, but they seem to predict things correctly, right? So I want to talk about something called a Michelson-Morley experiment. And I want to talk a little bit about, I want to mention something called Lorentz transformation. And talk about magnet through the loop experiment. And all together, this should lead us to Einstein's postulates. So Einstein's resolution to the confusion and his postulates. And then immediately we want to jump into the thick of the discussion of what those postulates imply. The three famous effects: non-simultaneity, time dilation, and length contraction. So we'll see as far as how far we will get through. Okay. So, okay. Michelson-Morley experiment. So let me build up to it. Okay. So on the one hand, we have this theory of electromagnetic phenomena described by Maxwell's equations, which works. On the other hand, it's not Galilean invariant, which at the time, in the 19th century, it was interpreted to mean that it violates principle of relativity. The theory was new, so naturally it seemed like we need to fix the theory and not the Galilean transformation or Newtonian mechanics. We already discussed just how awesome Newtonian mechanics is. Okay, so E&M described by Maxwell's equations they are not Galilean invariant. I'm sort of repeating what I said yesterday, or the day before, I think. But they work. Okay, and not Galilean invariant was thought to be synonymous with violating TOR. Or is it? It was assumed. Okay, and so so instinct is to fix E&M, or fix Maxwell's equations, or find some kind of a surface level solution. And not only are Maxwell's equations not Galilean invariant, but they also give predictions that suggest the existence of a special reference frame. Okay, so maybe it's not Maxwell's equations that have to be fixed, but maybe one has to accept that, well, Maybe POR is not the overarching principle of everything. Okay, so what do I mean by they give predictions that suggest the existence of a special reference frame? Well, one aspect of Maxwell's equations is that it predicts that a disturbance in electromagnetic field, not in the elastic field like air, but in the electromagnetic field, when you create a disturbance, for example, by wiggling a charge, okay, that disturbance propagates in all directions as waves with a specific speed. Maxwell's equations actually predict the speed of sound, which was checked experimentally long before that, about 2.99 times 10 to the 8 meters per second. And that speed is independent of the motion of the source, okay? Very analogous to sound, just like I said yesterday, the speed of sound relative, or velocity, speed of sound relative to the medium is independent of how fast the emitter is moving, because once the sound is created, it belongs to the medium. But the question is, what is this speed of light relative to? Okay, with sound, it was clear that speed of sound is the speed with which the disturbance propagates relative to the medium. Okay, now Maxwell's equations predict a speed. So what is it relative to? In other words, it suggests that there is a light carrying medium, just in the analogy with sound, right? So Maxwell's equations okay? So this number C, it pops out of Maxwell's equations. And so it's speed relative to what? Okay. It was thought, people started thinking, they thought that maybe Maxwell's equations in the form that they're written, maybe they're meant to be equations with respect to that light carrying medium, okay? All the experience up to this point suggests that waves require a medium to carry them, okay? And since the previous experience with wave motion in general, ocean waves, sound waves, had always involved a medium for propagation of waves, it was natural for physicists to assume that light needed a medium through which to propagate. So they assumed that this medium, which they called luminiferous ether, or just ether, permeated all space, was of negligible density, and had negligible interaction with matter. You don't feel it. And it existed solely as a vehicle for the propagation of electromagnetic waves. Electric and magnetic fields were thought to be strains of this ether. Just like, imagine if you have a mattress and you kick the mattress, there will be elastic waves propagating in the mattress. And these are waves of compressions, you know, stretches and compressions of the mattress. And people thought that the meaning of E and B fields that you study in E&M is that these are somehow, that they somehow have a mechanical meaning behind them, and that they describe the strains of this ether, much like a compression of an elastic medium. And then people thought that electromagnetic waves are waves of this elastic strain, right? Just as sound waves just as sound waves are waves of elastic strain of a sound carrying medium. And then it was thought that speed c is a speed relative to that ether, just like the speed of sound is implied relative to the air. In other words, people try to seek a mechanical analogy. Okay? By the way, I'm not writing down everything that I'm saying. It would be too much to write. So I think you should still take your own notes and write down what comes across to you, even if I'm not writing something down, because I'm just writing down basic bullet points. Anyway, recall what happens with sound. If you're writing in a convertible and you make a sound, like a beep, a clap, or a pulse, this beep propagates with a fixed speed relative to the medium, or air. So its speed relative to the convertible depends on the speed of the convertible relative to the air. In fact, if the convertible moves through air at the same speed as the sound moves through the air, the observer in the convertible would see the sound standing still. Okay. So if the same thing happens with light, it would mean that while you're inside a spaceship, you shine a flashlight, and this light from the flashlight inside the ship moves at a different speed through the ship, depending on how fast the ship is moving through the ether. So again, existence of ether violates principle of relativity. You can tell how fast you're moving without looking outside, just by shining a flashlight inside the ship. If you have questions about doesn't sound violate principle of relativity, if such a question does cross your mind, bring it up. Okay, we can discuss it in the forum or at office hours. But if such question didn't cross your mind, don't think about it. Okay. In any case, sound is not problematic. But if this happens with light, it is problematic because it affects one of the basic laws of nature, Maxwell's equations. So anyway, obviously you want to look for this ether, right? And if maybe not in the sense of like capturing it in a bottle, at least as some kind of an experimental validation that yes, indeed it exists. And yes, light is a mechanical phenomenon, just like sound. And while it violates POR, so be it, something like that. And the most famous experiment in this regard was conducted on the campus of what is now Case Western Reserve University in Cleveland by Michelson and Morley in 1887. Okay. These are kind of like bullet points. The experiment is described in your textbook, and you should read it. It's in the appendix. In short, the idea is this. It's just the sketch. If the space is permeated by ether, and Earth rides through this light-carrying medium, ether, then just as in our convertible example, the light that's traveling in the direction of the ether headwind will take a different amount of time than the light that travels in the opposite direction or in the perpendicular direction. Light is a wave, and time delay between the two signals implies the phase difference between these two waves. So we can measure the delay using interference, because light is a wave, because the sound is a wave. So Michelson and Morley used a very sensitive apparatus known as interferometer to detect these time differences. And they found none. Okay? Now, I can fill in a little bit more detail than just saying what I said. Okay, so consider, well, first before, okay, so let me just say Michelson and Morley used interferometer. So let me explain. Think of a convertible type experiment. Okay, let's send a signal from one end of the car, reflected by a mirror, and receive this reflection. Okay, so here's our convertible car. It's getting simpler and simpler. I'm going to send a signal. Okay, this is a mirror. And I'm going to receive the reflection. Okay. You can use formulas from yesterday. Okay, and you will see that the total time, so send and receive, of the light's trip, there and back is, you should check, it's given by 2L over S, quantity divided by 1 minus V squared over S squared. You add up one expression plus the other, one with S minus V, the other with S plus V. You bring it to a common denominator, you clean it up, and then you can see that it's like that. Okay, so that's the time of the trip there and back. On the other hand, if we shoot a signal up, perpendicular to the car's motion. So here's the car. Oh man, the car is just changing. Right, so but let's say I send a signal up. Okay, let's say I have some kind of a reflector, and the car is moving, right? So this is so I'm sending this signal, and so the signal, you can think of, I'm emitting rays, or I'm emitting waves in all directions. One of them will hit the mirror, then it will reflect in all directions, and one of those will hit the front receiver. So this is what it's going to look like. So this is the car when it was sent, okay, and this is the car when it was received. Okay, the car is moving. And so you can do the calculation, and you would find that the time of trip up and down is actually different. It's to L over S divided by the square root of 1 minus V squared over S squared. So on the one hand, I have left and right. And on the other hand, I have up and down. So I'm emitting waves both here and here. They reflect. One reflects from this mirror, the other reflects from this mirror, and then they come back, and then they recombine. They come back home. And if we combine this signal, because they take different amount of time, they would be out of phase. And this phase difference would give rise to the interference phenomenon. I have this signal, and then I have up and down signal, and then I would get different delta t. It means different phases, out of phase, which means interference. I don't know why it's not. Something's not. Okay. And so, so you would get interference. Okay, so depending on the length of the car, Sometimes they would be pi out of phase, sometimes between pi and 2 pi, sometimes 2 pi. So you can control the length of the car, or you can do something. You can see that you get interference effects. Okay, and that's basically the sketch of Michelson and Morley experiment. But it's described in much more detail in your appendix, in the appendix of your book. Long story short, no interference. Okay. But people are not ready to, they're not so happy to give up on things. So they dug in their heels, and they were not ready to give up the idea of a preferred reference frame for electromagnetism, the idea of a light carrying medium, because it's true for all other ways. Why wouldn't it be true for this way? And so obvious patchwork fixes started pouring in. For example, it was proposed that perhaps the Earth, experiment was done on the Earth, drags ether with it. So there's no wind relative to the surface of the Earth. And it's not such a crazy idea, actually. If you stick your finger just outside the airplane, the air is actually not moving, okay? The air doesn't do this next to the airplane. There's a velocity profile. It takes some distance away from the plane for the air to start moving. And that has to do with friction, right? So the air right outside the airplane is still relative to the airplane. It's not sliding past the airplane. So in any case, all of these at face value solutions were complicated, they were not elegant, and some of them created more problems than they were meant to fix. And one way or another, they did not produce a convincing resolution to the problem. And so a solution at a very deep level was needed. And that's the subject of the next section of this lecture. See you soon.